Hello guys, this is section 4.8 talking about complex numbers. A complex number, we mentioned this back in chapter 1, it's a subset of a larger group, real numbers is a subset of a larger group called complex numbers. And if real numbers are pretty much everything in the world, complex numbers are actually a little bit bigger than that. And that's kind of what we thought about so far with real numbers. Complex numbers are a little goofy because what they involve is they're based on a number whose square is -1. And we call this number I. Now I in this case here is a number. A common mistake is treating I as a variable and not as a number. So I squared equals -1. Okay, we're going to have to take a second and wrap your minds around that. I know it's a little different. That also means if I squared is -1, then I itself is equal to the square root of -1. Okay, and these are some things that are going to play into what we do going forward here. But we have to remember first some of our properties of radicals as we work through this section. So a quick review here. We're going to go through these real fast. Simplifying radicals. Whenever you simplify a radical, like this first one here, square root of 20, we want to break that down into two factors of 20, okay? And ideally you're looking for at least one of those factors to be a perfect square, such as 4. The reason we do that is because then we can treat this as the square root of 4 times the square root of 5, once we've broken it up like that. And the square root of 4 becomes 2. So this answer then becomes 2 times the square root of 5, or 2 radical 5 is what you'll hear me say a lot. That's the kind of model that we want our answer to look like. You always want the largest number possible out front, and then whatever you're left over with goes under the radicals. Okay, so you look at what we started at, square root of 20. Like 20 is something that can be simplified down, so 20 is not the smallest thing under the radical. 5 in this case is. Next one over, square root of 32. We can break this down. There's a couple options we could do. Let's just say we do 2 and 16. Okay. Again, we chose that because 16 is a perfect square. You're generally thinking factors of 32, and you want to find some that are perfect squares. So that's why I chose 2 and 16 here. So this becomes radical 2 times radical 16. Square root of 2 doesn't change, but what's the square root of 16 become? It becomes 4. Now we generally always write our answer with the whole number in front. So 4 times the square root of 2. That's how we will leave this as a solution. Okay. How about square root of 44? How about 4 and 11? So we get square root of 4 times square root of 11, which equals 2 times the square root of 11. You know that you are finished when the number under the radical cannot be simplified any further. 11 is a prime number. There's nothing else we can do with that. Let's look at the square root of 108, though. This one has a lot of factors. For 108, 2 and 54 is an option. 3 and 36, 4 and 27, 6 and 18, 9 and 12. I think that's about it. There's a lot of perfect square factors I see. I see 36, I see 4, I see 9. A lot of options here. Generally, you want to choose the largest perfect square possible. So like 3 and 36. 36 is a perfect square. But let's just say I chose to do 9 and 12. It is not wrong. Watch how this works. 9 and 12 you can break up into the square root of 9 times square root of 12. Square root of 9 becomes 3. And then you've got square root of 12. Now, here's where we got to go a little further. 12 can be broken down into square root of 4 times the square root of 3. So I can take that and break it down even further. In that case, we will get 3 times square root of 4, which is 2. So we have 3 times 2 times the square root of 3, which is 6 times the square root of 3. And so that's what our answer is there. Now let's say, just again for sake of whatever thoroughness here, let's say I chose originally to break that up into 3 and 36. not wrong. It's totally right. You're going to get the same answer here. Watch. You'll get square root of 3, square root of 36. Square root of 3 doesn't change. What's square root of 36? That becomes 6. So check that out. Our answer is the same thing. It's just that it took us a shorter time to get there when we chose a larger square to start with. Okay? Nothing wrong with that. Square root of 200. Let's make this 102. So this becomes 10 radical 2. Okay. And the last one, square root of 96. Break this down again. A lot of options here. I'm going to choose 16 and 6 because 16 is a perfect square. So that gives me 4 times the square root of 6. Can we break 6 down at all? Well, we could break down to 3 and 2, but that's not going to do anything for us because neither of those are perfect squares. So we can just leave our answer as 4 times the square root of 6. Okay. Now, I went over all that because we have to be good at working with radicals here when we use imaginary numbers. So take a look at this first example. It says simplify the square root of negative 18. First thing you always want to do whenever you have a negative underneath the radical is you want to essentially pull that negative out. So what I mean by that is break it up into this, square root of 18 times the square root of negative 1. You're just kind of pulling that negative 1 out. Now you got to leave it under the radical, right? We're not like foiling, or we're not pulling it out of a parenthesis or anything. Okay, we're just breaking that apart. Now, the reason I do that is because let's go back to what we said about I. We said that I squared is negative 1, and that also means that I is equal to the square root of negative 1. Okay, now this is going to come into play here. Back to this, we have square root of 18. I can break that down into square root of 9 times square root of 2. And then I've got this square root of negative 1, which we just over here said was equal to I. So that's going to become I. Now, square root of 9, we can go ahead and simplify this. That becomes 3. So we have 3, we have the square root of 2, and we have I, all being multiplied together here. The way we would construct that at the end is 3I times the square root of 2. Okay, 3I is that part that's going to go in front of the radical. Okay. Let's do the next one, square root of negative 25. Well, first thing we want to do, let's take that negative, pull it away. Let's separate that negative 1 out. Square root of 25, that becomes just 5. And then square root of negative 1, once again, there's that I. So this is kind of a simpler one. It becomes simply 5 times I. The next one, simplifying to square root of negative 12. Okay. Think of this as square root of 12 times square root of negative 1. So that means we're going to give me square root of 4, square root of 3. And then this is square root of negative 1. So square root of 4 is 2. Square root of 3 stays. This guy becomes I. So then our answer is going to be 2I times the square root of 3. Okay, I know this all might seem kind of crazy, but right now you got to just trust that the I kind of fits in. Okay, it'll hopefully make more sense as we continue to go. Right now you're just going to kind of roll with these answers. Okay, hopefully you can see how we're getting it and where this is all coming from. The last one on this page is this. It's a question for you. Is the square root of negative 64 equal to negative square root of 64? Okay, so let's think about this for a second. This first piece here, we can break down like we've been doing into this, square root of 64 times the square root of negative 1, which is going to be 8I, versus this guy over here is going to become negative, and then the square root of 64 is just 8. So is 8I equal to negative 8? Our answer for that would be no. These are not the same thing. So what I want you to see from that is that negative signs are very important. You cannot just take them for granted, okay? Okay, good. So that's kind of the introduction to imaginary numbers. This is the first part. I will do the second part here momentarily. That's going to be adding, subtracting, multiplying, and working with some of them that way, okay?